When you chat others on an application like WhatsApp or Messenger, have you ever thought about how it works? So if we take a deep look at how these applications work, we will find that these applications work with the mechanism called inter-process communication. So what is the inter-process communication mechanism? Process communication is the mechanism provided by the operating system that allows processes to communicate with each other. Processes within a system may be independent or cooperating. An independent process is not affected by execution of other processes, while the cooperating process can affect or be affected by other executing processes. In this video we are going to talk about only cooperating process. So why cooperating processes? Cooperating processes good at information sharing, computation speedup, modularity and convenience. In order to exchange data among each other, multiple processes may need to communicate with each other by inter-process communication or IPC. Fundamentally, there are two main models of inter-process communication: shared memory and message passing. We will focus on message passing in this video. Message passing model allows multiple processes to read or write data from or to the message queue without being connected to each other. As you see, both the processes P1 and P2 can access the message queue and store and retrieve data. Even though the message passing is easier to build parallel hardware using message passing model, as it is quite tolerant of higher communication latencies and easier to implement, but it is only useful for exchanging a few values between processes. Additionally, message passing systems are relatively slower than shared memory because they are typically implemented by system calls and hence require more time to execute, as they require kernel intervention. Inter-process communication facility provides at least the two operations: send message and receive message, and the message size is either fixed or variable. For example, if processes P and Q want to communicate with each other, they must send or receive messages to or from each other. Communication link must exist between them and exchange messages via send or receive. This link can be implemented in two ways: physical implementation and logical implementation. We are concerned here with logically implementation. There are several methods for logically implementing a link and the send or receive operations: direct or indirect, synchronous or asynchronous, automatic or explicit buffering, send by a copy or send by reference, fixed-sized or variable-sized message. We start with direct communication. Under direct communication, each process that wants to communicate must explicitly name the recipient or sender of the communication. The properties of communication link in direct communication is: the link between them is established automatically. A link is associated with exactly two processes. Between two processes, there is only one link, and the link may be unidirectional or bidirectional, but is usually used bidirectional. That means the sender may receive messages and receiver may send messages. Secondly, we have indirect communication. In indirect communication, the link between the sender and the receiver is done via a port or mailbox instead of direct addresses. The port acts as a mailbox for the messages. Each mailbox has a unique ID and unique owner, and the sender doesn't need to know the exact ID of the receiver. The sender simply sends the message via a mailbox and the receiver collects the message from that mailbox. The properties of communication link in indirect communication is: the link is established between a pair of processes only if both have a same shared mailbox port. The link may be associated with more than two processes, and there may be different links, with each link corresponding to one mailbox, between pair of communicating processes. The operations occurring when a process wants to communicate with another process are: first, create a new mailbox or port. Second, send and receive messages through mailbox. And finally, destroy a mailbox. So when a process that owns a mailbox terminates, the mailbox disappears. Any process that subsequently sends a message to this mailbox must be notified that the mailbox no longer exists. Message passing may be either synchronous or asynchronous. In case it is blocking, is considered synchronous. In blocking send, the sender can't send any message until the message is received by receiver. While in blocking receive, the receiver can't receive any message until a message is available. If both send and receive are blocking, we have a rendezvous. We will explain this in next section. In case it is non-blocking, is considered asynchronous. In non-blocking send, the sender can send the message and continue with no limit of messages. While non-blocking receive, there are two cases. If message is valid, the receiver can receive messages with no problem. And if there is no messages, the receiver receives a null message. Now we will take about buffering. Buffering is a queue of messages attached to the link. There is 3 ways to implement it. First way is zero capacity. It's called rendezvous. In this way the queue has a maximum length 0, so the link can't have any messages waiting in it. In this case, the sender must be blocked until the recipient receives the message. Second way is bounded capacity. In this way the queue has finite length n. Thus, at most n messages can reside in it. If the queue is not full when a new message is sent, the latter is placed in the queue, and the sender can continue execution without waiting, while in case the link is full, the sender must be blocked until space is available in the queue, because the link has a finite capacity. Third way is unbounded capacity. In this way the queue has potentially infinite length, so any number of messages can wait in it. The sender never been blocked. The buffer size and message size affect in communication in 2 ways. The first way, message has fixed size, which the system-level implementation is straightforward, but it makes the task of programming more difficult. The second way, message has variable size, which require a more complex system-level implementation, but the programming task becomes simpler.